Yes. What? I don't know. The audio. Okay. Yeah. Okay. Uh, Hello, good morning, everyone. Good evening, Professor Murray. I think it is night here in the United States. Thank you so much for giving us your time and accepting our invitation to join as a keynote speaker at KICSS. Yeah, so ladies and gentlemen, let me introduce Professor Mari, our first keynote speaker of today. So Professor Murray is a professor at University of North Carolina, at Charlotte, United States. She is a co-director of the Human Centered Computing Lab, as well as she held many positions at different prestigious universities all over the world, particularly the United States. For example, MIT, Columbia, and also she worked at United States National Science Foundation and worked and other global universities like University of Sydney, the university, and etc. So her research mainly focus on intersection of AI and HCI, human computer interactions. She recently worked on the areas including AI-based model of novelty and surprise, evaluating ideation and human AI co-creativity, which is in line with our conference focus. She's working on AI to support creativity and enhance creativity, initiated based on human ideation or creativeness. So human-centered AI interaction design and personalized learning system that encourage ideations. So it was my pleasure to meet Her at IGCI conference, she was also one of keynote speaker at IGCI. So we invited as organizer to ask her to join KICSS, and she kindly accepted our offer. We would like to thanks again her to give us her valuable time to deliver a keynote. Thank you so much, Professor Mari. Yes, it is, and the floor is yours.
Thank you so much for inviting me. I'll first check that you can hear me.
Yes, we can hear you. So,
oh, great. Thank you.
Could you please share your screen? So I'll stop sharing mine.
Okay, thank you. Yes, let me share my screen. So I assume you can see my screen now?
Yes, we can see your slide. Yes.
Excellent. Thank you very much. And thank you for inviting me to give a keynote talk here. You know, I see that creativity is one of the main topics of your conference, and I'm very excited to talk about my research on creativity. And today I'll be talking about enhancing human creativity through the synergy of symbolic and connectionist models. And you might, you know, want to try and figure out, what does that even mean? I think we've all been both excited and surprised by the abilities of the deep learning models and large language models that have been released recently, and their claims to being creative. And so my talk here is almost sort of in response to that, by trying to bring together these new ideas, large language models, generative AI, and the previous research that's been done on symbolic AI, and see how they can together be stronger than any one of them on their own. And so just to put my work into context, if you look at the bottom right of this slide, there's an area of research around creativity support tools. And I noticed that this conference series over many years has been looking at creativity support tools. And these are where we develop computational systems that accelerate the creativity of humans. And it helps them. It makes them more productive, efficient, and aids them in their creative process. It isn't creative. The computer isn't creative, the human is. And on the left-hand side, where we've seen research on generative creative systems, and that's where the computer system or the AI system is creative alone. And this area of research has been going on for decades. So we have had programs that can generate music, can write poetry, can paint paintings, and requires very little input from the person or the user. It is really a standalone creative system. And what I'm talking about today is research that's been going on for about a decade on bringing the benefit of both of these into something that's called co-creative systems. And that's where the human creativity and the creativity of the computer system work together. I'm going to just now put it in the context of what we've been seeing in the news, and maybe many of you are using these tools. And DALL-E 2 is the example on the left, and that's a multimodal large language model that can generate a new image from a natural language description of that image. And many people are claiming that this is highly creative. It's going to put artists out of work. That now we have an AI that is as creative as humans. And on the right-hand side, we can see an example of creativity in a technical field, and that's the GitHub Copilot, where it can generate code based on completion of code that you've already started, or a specification of what you want the code to do. Now, these two examples are possibly considered co-creative, but the human has very little input on the creative process other than to request or direct it. In contrast, we look at some co-creative systems where they are truly collaborative efforts between the AI and the human creator. The one on the left is a system called Shimon, and this is a robot that plays music at the same time as a human player plays music. So it's improvising. It's generating music real time in response to what it hears from the human. So it's not about generating music as a standalone system, but generating music in collaboration with a human musician. And the one on the right is the drawing apprentice, and that does a turn-taking drawing activity where the human draws and then the AI looks at what the human has drawn and adds its contribution to the drawing. Now, these two systems were released maybe 10 years ago. And so they weren't using deep learning or large language models, but using symbolic AI systems. So with that very brief sort of overview of how did we get here, I want to talk about three things. One is what are the foundations for AI-based co-creativity? And here I want to talk about AI. And then the second thing I want to introduce is some co-creative systems that I've been developing as part of our research to see what our research goals were. And these are examples of AI-based inspiration for human creativity. So it's not necessarily about how creative is the computer, but how can AI inspire us to be more creative? And then I'll finish up with a few slides on how do we combine these decades of research on cognitive models of creativity with this more recent research on deep learning or connectionist models of creativity. Because, as you may know, when you build a cognitive model, you develop software that mimics human reasoning and human thinking. And when you build a connectionist model, you train it with data. You don't have human reasoning in there. What you train it with is the data that is the result of human reasoning. So they have very different representation models that arguably cannot be combined because there's no data in the cognitive model and no reasoning in the connectionist model. I want to start with the grounding problem, which is originated from the philosophical basis for AI systems. And the symbol grounding problem has been around since 1990. And the question was, how can an AI system acquire meaningful semantics from a purely symbolic representation? Why, in fact, does it have meaning to us if we write a program to paint a picture, to generate music? How is it that those symbols have meaning in a world where we exist, where we don't have that approach? We aren't methodical like the computer is. And the vector grounding problem, very recently proposed in 2023, asks a similar question, and that is, how can the manipulation of vectors in a deep neural network produce representations? For example, ChatGPT manipulates the vectors in the latent space of a deep learning network and then translates or decodes those vectors into words, and they have meaning. How is that possible? So there's many types of grounding. I'll just point out two of them. The sensory-motor grounding is when a lexical concept is linked to sensory-motor representations. For example, in a robot, where the movement of the robot is the link between the real world and its internal representation. As it navigates through a physical space, it's constantly grounding its representation with feedback from the physical space it's in, through vision systems, or through sound systems, or through mechanical movement of its wheels or legs. And I won't talk about that here because we're not talking about robots when we're describing co-creative research, but I'll talk about the bottom one, which is referential grounding. And that's when we claim that the connection between an internal representation in a program or in a latent space is mapped onto something we understand or has meaning in the world. So the word dog, which could be dog in a symbolic model program, there could be a variable or an object called dog, or it could be a vector for the word dog in a deep learning large language model, is grounded in what we mean by dog in the real world. And that this connection, referential grounding, is the basis for neural networks and symbolic AI to actually be able to communicate with each other because the word is the same. And here's a diagram of what that might mean. You might have a symbolic model based on cognitive models of creativity, surprise, planning, design, classification, and those have symbols in them. And those symbols map onto a concept in the world. Similarly, that symbol, the word planning, the word creativity, is a vector in a generative model, and they both map onto the same concept. So the link can be through that concept in the world. There's a number of books and models over many decades of cognitive models of creativity. These are some of the books that I've worked on, but I also wanted to point out The Creative Mind by Margaret Bowden, who was a leading psychologist, philosopher, and AI researcher, where she talked about different kinds of creativity, again, based on cognitive models, based on our observation of how humans are creative. We put that into computers in a reasoning process that was similar to how humans reason about creativity. And Margaret Bowden talked about 3 kinds of creativity in human cognition that could be transferred into AI systems. And combinatorial is when you take 2 or more concepts and you put them together and their combination is novel. Exploratory is when you're in a design space of symbols and representations of designs, and those designs could be poems, it could be music, it could be buildings, it could be anything that humans have designed. And exploratory is when you search in that space for the parts of the design space that nobody has looked at yet. And then finally, transformational is when the concept is actually not in the design space and the boundaries of the design space are changed through creative reasoning, and you come up with ideas that nobody's had before. And what we've seen with our deep learning and our cognitive models of AI creativity is examples of combinatorial, combining 2 words, putting them together in a way they weren't used before. Exploratory, getting to parts of the language space or the image space that nobody has seen before. But we haven't really seen transformational creativity from computers yet. Still, we see that from humans. And so I guess the benefit of including humans in the co-creative process is to enable creativity that goes beyond the kinds of creativity that AI is capable of. When we look at creativity from deep learning models, we are, for many years, we were building our own models, and I'll give some examples of those. And those are where you are training a model with data. So the data is based on human output of creativity, human output of language, and the autoencoders take the language or the images as input, and they encode them into some vector space, and then they decode them back into the output space of language or image. And it's that internal representation that is that vector space that we can use for creative reasoning to add for combinatorial, to explore unusual vectors that don't show up very often, novelty, to get to output that is considered creative. There's no reasoning per se, but there is algorithmic operations on that internal representation. What does this have to do with human-centered creativity? Because that makes it look like the AI is doing all the work. And I introduced the Wundt curve, which was developed by a researcher called Berlin. And this was actually introduced in 1960 as a way of characterizing how people are inspired to be curious or creative by varying the novelty of the stimulation. And so this shows that if it's not very novel, if the stimulation is not very novel, then the person is probably not going to notice it. It's not going to inspire creativity or curiosity. On the other hand, on the right-hand side, if it's very novel, it's going to cause stress or dislike because it doesn't have enough to do with what the human is thinking or experiencing, so they'll ignore it. So there's this comfort zone, it's called in the diagram. At some point, it's novel enough, not too novel, to inspire creativity. And the AI systems that we developed used computational creativity to inspire the user, the human creative, in that comfort zone. And so coming back to that very first slide, we can train deep learning models on data sets of products in the design space where that user is working. It could be programs, images, music. And that would allow us to build tools that could navigate that space and produce combinatorial or exploratory creativity. In the second row here, AI inspiration based on cognitive models of novelty and surprise gives us a way for generative systems to come up with things that are novel, that we haven't seen before. But the real power of this is when we transition from computational tools to computational partners. How can the human and the AI work together? So now I'll describe some of the systems that we've designed, what research we did, what we were interested in learning from the system design. And they all have a very similar, let's call it a architecture, system architecture. On the left-hand side of this diagram, you see a user in front of a user interface. And on the right-hand side, you see an AI with its own interface. So the AI is placing an inspiring sketch. We worked in our research on sketching, an inspiring sketch on the right-hand side, and the user puts their sketch on the left-hand side. Now, we did this with sketching, but you could think of it as poetry. You could think of it as problem solving, building design, where the user has their space and the AI has their space. And the AI is intended to inspire the user, so the user can copy and paste what it likes from the AI into their space. On the left-hand side, you can see what models we have of human creative reasoning. One is idea generation, and the other is problem solution reframing. On the right-hand side, you can see that we have pre-trained large language models, we have pre-trained deep learning models, and we have cognitive models. And those are the components of the AI as a basis for the inspiration. Down at the bottom, you'll see that one of the research projects I'll talk about talks about how the human and the AI can communicate with each other and not just through the product. In the user interface you see here, the AI can see what the user has drawn, the user can see what the AI has drawn, but we added another dimension, which is the user and the AI can sense each other's, in our case, emotion detection, but can also understand the language that they're using. So one of the foundational systems we built was the creative sketching partner. The left-hand side is where a user or a participant in our study was given a design task, design a bridge to cross a river near a national park. And they were asked to sketch their design. And when they wanted inspiration from the AI, they would choose on that slider how much visual similarity they wanted and how much conceptual similarity. And then they would hit the inspire button. And then they would be able to get as many inspirations as they wanted until they were happy with their design. And we use this system to study ideation, to study the kinds of creativity that resulted through this collaboration was somewhat dependent on how novel the inspiration was. And we thought that the more novel it is, the more transformational the result would be. And the less novel it would be that kind of combinatorial creativity. And that somewhere in the middle, we would see that exploratorial creativity. The way we built the AI system was the visual similarity was based on image stroke data, and the semantic similarity was based on the words that were used to describe the image. And so we had a process for deciding which sketch to give to the user from the AI into the inspiring side of the interface. So the user would sketch, and then the AI system would extract the stroke data, the visual features, and then it would locate it in a cluster of sketches based on the deep learning model. And then in the conceptual shift, it would send the words of the sketch into a word2vec and then calculate semantic similarity. And then through semantic words, visual stroke data, it would have 10 images in the category of high, so 3 or 4 in the high, 3 or 4 in the intermediate, 3 or 4 in the low. And then depending on where the slider was, the target sketch would be put into the inspiration. This one gives more detail. I won't go into this one, but I just wanted to show that it's not quite that simple. We had to do a lot of clustering algorithms and feature extraction. So here was our hypothesis: high similarity combinatorial, intermediate exploratory, transformational, low. And we did a study where we had 3 different design tasks, and that the inspiration for that design task would either be high, medium, or low similarity. And then we showed through our analysis of the results and our coding of the sketches that when there was low novelty, we could demonstrate how that the sketch that the AI used to inspire them was basically copied and pasted, and through combinatorial, the 2 sketches became part of the final sketch. Then we showed how for exploratory creativity, the person would resketch, and the sketch would not be a combination, but it would be an emerging sketch that looked a little bit like both, but not the same. And then for high novelty, this is when, for example, the person is sketching a chair and the AI inspiration is a speedboat, or the person is sketching a chair and the AI inspiration is an aircraft carrier. And again, we saw then that they came up, the human participants came up with designs that were not typically chair designs. So that was looking at the output. And then we wanted to look at ideation. Does it change the way humans think? And if it does, how can we measure that change? And so we did another study where we had two conditions. The inspiration would be randomly selected from a curated data set of images, or it would be based on visual and conceptual similarity where the AI decided which image to use next. And the AI gently moved the person from similar to novel throughout the process. Then we had to measure ideation, and we came up with a model for measuring the novelty of the ideas, how different was the next idea from previous ideas, the variety of ideas, and that was how many different ones. The quality of the ideas was done through qualitative coding by an expert designer, and then the quantity of ideas, how many ideas, novel or not. And then we also looked at the process. So when it was the random condition, which you see on the left, there were many times when the user would ask for inspiration and then ignore what it was given. And there, in the AI-based, the visually similar, conceptually different, when the AI produced the inspiration, we saw more often that the user would change their design in response to the inspiration. They didn't say, I'll ignore that one, let me try again. Now I'm going to jump into Arnie. Arnie was, remember that diagram down at the bottom of the systems diagram that said emotional detection. And in this one, the decision about how novel to make the inspiration was based on the human participant's emotional state. So the human participant was given a design task, and the AI had a set of rules that said, if their person is expressing a negative emotion, do one thing. If they're expressing a positive emotion, do a different thing. And if they're not expressing any emotion, don't do anything. And so we had 6 participants, did a case study and thematic analysis of their interviews after they completed their design. And we had them watch the process of co-creation, and through a retrospective analysis, they described what they were thinking when they were interacting with the AI. So this just shows our rules. It's a little bit hard to read, but if the person was feeling positive, then the AI would give them something similar to what they were doing already. And if the person was feeling negative, then they would give the inspiration would be highly novel. It would be there to sort of make them think about something else. And if it was neutral, the AI would just pass. It would say, okay, I'm not taking a turn, you go again. And their results showed that when the emotion detection was there, the interviews with the participants included things like, boy, Arnie really understood when I didn't like something. And it gave me space to develop my ideas. It cared about what I did. It was kind of freaky. And so having just that emotion detection made the person feel more like the AI knew them better. We also found that with emotion detection, the resulting drawings were a little bit more organized, a little bit more coherent, where without the emotion detection, it's kind of messy because the AI would contribute something, the person wouldn't like what it got, so it just sort of push it off to the side, and it got kind of cluttered. So in summary, what we've talked about so far is that the cognitive models that we developed provide a concept space, the concepts of novelty, similarity, conceptual novelty, visual novelty. All of those were based on cognitive models of creativity. But the neural network models gave us a mathematical vector space to actually measure similarity. So the components were very different. And then the interaction between the human and the AI had two different ways that the human interacted. One was intentional, so they could say, inspire me, and the person could indicate how much novelty they wanted. But then we also used what we call consequential, and that's where the person is not communicating with intention, but the system is just measuring emotion from their face. So they're not expressing that they're sad. They're not doing a thumbs up or a thumbs down. It's detecting it from facial expression. And those two are very interesting. It was very interesting to see that emotion detection had such a strong impact on the user's perception of how smart the AI was. And then finally, how did we quantify or characterize our results? We used cognitive metrics for ideation, where we turned cognitive ideas into measures. And we did qualitative analysis through our interviews about how the user actually felt about the interaction. And when they thought of the AI as a partner rather than a tool, that the user felt like they were being more creative and that they trusted the AI more. Now, coming back, I'm going to wind down now and see if you have some questions, but I wanted to come back to that combining symbolic and connectionist models. There's three, I guess, categories of approaches, and that is where you have a connectionist model, a deep learning model, and inside that, you embed symbolic models of creativity, surprise, expectation, and novelty. But the connectionist model is the input-output response. The other one on the right-hand side says you have symbolic models, so you have programs that use the words and the reasoning that humans use, and they call a deep learning model from within the symbolic model. And then that third one is you maintain a separation of your symbolic models and your connectionist models, and you allow your symbolic models to advance, and you allow your connectionist models to advance independently of the co-creative system. So coming back to some of our systems where we had the co-creative interface at the top, AI inspiration on the right, human design on the left, and that the cognitive model was responsible for sensing and characterizing what the human was doing, and then it prompts a deep learning model, which responds, and then the response from the deep learning model is modified by the cognitive model and sent back as an image to inspire the humans. And so you look at this as a kind of a system architecture. We're beginning to see how cognitive models can generate prompts. Right now we have humans generating prompts, but we're beginning to see people developing AI to generate the prompt. And the prompt is based on what the user wants without the user having to understand prompt engineering enough to generate the prompts themselves. And then here are my conclusions, and we have time for questions. I have a summary on the left, which says that, first of all, cognitive systems to support human creativity are based on the psychology of human creativity, and that large language models are based on the data generated by humans as a consequence of human creativity, and that co-creative systems include the human in the loop. It's not just about AI producing creative solutions, but including the human. And how can you do that? How is it meaningful for the human to communicate with the AI? It's possible for this concept of referential grounding, that because our words, our language is grounded to what we mean in the world, the AI that generates creative artifacts or inspiration for creative artifacts has meaning to us as well. And then on the right-hand side, the benefits of combining cognitive and connectionist models. Why not just go with a large language model and ignore all the work that's been done on cognitive AI, because we've seen that these large language models are so capable. Do we need cognitive models? And I think we do, because I think we would have a stronger AI system if we maintain the cognitive models to represent abstraction and reasoning, while combining them with the robustness that we have in generating meaningful new images or text through the large language models, which don't have the fragility of cognitive models. In a cognitive model, if you introduce a word or a concept that wasn't programmed to understand, it won't be able to do anything with your input. But large language models, based on the vast amounts of data that they were trained on, it's very hard to find a word it doesn't know. And so it's very robust. And then I've only talked about co-creative systems and how cognitive models of creativity can be used to guide these deep learning models. But if we were to develop cognitive models of human values, such as ethics or explainability, then we could think about how these cognitive models can be used to provide ethical guidance or to explain large language models. I've published quite a few things on these topics. In my slides here, I have a list of the publications that are relevant to the work that was being described here. And I do want to acknowledge my many collaborators at UNC Charlotte and Georgia Tech and other universities, and see if you have any questions. Thank you.
Thank you very much, Professor Murray, for wonderful and excellent speech. It is really amazing to see co-creative systems how AI can inspire co-creative systems, and you are mainly focusing on the transforming the creativity of human-based ideations, and how the creativity of human can be realized and accurately using some AI methodologies. That's very, very interesting topics, and it really be a meaningful way to not just use AI to propose some design or solutions or rely based on AI approaches, but that's important or more meaningful to realize or relay based on human creativity, and use some support tools or systems which support these creativity process. That was a very, very interesting talk and lecture. So let's go to audience. So if you have any questions from Professor Murray, please feel free to come here and ask your question. Okay.
Oh, okay, okay. I have a question. One
Yes.
question.
Yes,
Okay.
indeed.
Thank you. Thank you. Very wonderful talk, I think. So, my question is that did you evaluate about group creativity? So,
Yes. You
yeah,
mean like collective intelligence or bringing diverse groups together? So
exactly. Yes. Yes.
there's human group creativity, and then there's also multi-agent systems where
Yeah,
all of
both actually. Yeah, my question is
yeah. So I think in our studies we do just look at the pair, just one human and one AI. But I did earlier work on multi-agent systems and collective creativity, but not where it was a combination of people and a combination of AI. I've only looked at all people or all AI. How about you? Have you looked at where there's many AIs and many humans?
Yeah, actually, we are doing that experiments currently about discussion and a creative discussion. So,
Hmm.
yeah, it's yeah, we are obtaining a very interesting result now, and your talk is really related to what we are thinking now. So, yeah, I'm happy to be here. Thank you.
And so the basis then for the creativity is language, right? Talk about discussion.
Yes.
Yeah,
Only language. Yeah.
very interesting, because with the large language models, I think that is a very good topic to explore, because the language models are so capable.
Mhm.
So yeah, that sounds
I
very
agree.
interesting.
I agree.
Yeah.
Thank you. Thank you.
Okay, thank you.
Thank you. Any another question? Okay, I have a question. In your talk, you mentioned a very key point that an AI method or product should be novel in order to enhance the valuable creativity process of humans. So, could you please elaborate more on the novelty of the AI tool? From which parameter you are focusing on the novelty? I mean, what are the index in order to work on that part to design the AI in order to support the valuable creativity?
So the way we measure novelty in the AI is not novelty in the world.
Yeah.
So it's not how unusual is it in the whole world of design, but how similar is it to what the human user is doing right now. And in our systems where it was about sketching a design solution, there were two indexes. One was the sketch of that the person was producing. So they're sketching a chair, and it used that stroke data to as input into the neural network that would then encode it into a vector, and then it would measure how close other sketches are to that, and it would very similar is less novel, not similar at all, far away in cosine similarity distance would be novel. And so we measured novelty, measured it as a cosine similarity between two vectors in the neural network based on sensing the sketch that the person made and all the sketches that were in its data set. The second index was what we called conceptual similarity. If it was a chair, then it would use word2vec to find words of sketches. So we had, 30,000 sketches. in the database. So we had 30,000 words. And we would take the word chair and use word2vec to give us a vector. And then we would put in the names of all the 30,000 sketches and get vectors. And we would find vectors that were close to chair. And again, using cosine similarity between the vectors. And then chair might be like similar to a sofa. And it sends a sofa. And chair might be very different to a bed. So it sends a bed. And so it used two indexes, the stroke data from the sketch, and then the words used to describe the images, and then cosine similarity to measure distance.
Yeah, that makes sense. Yeah, very interesting. And so we have 1 more minute. So if you have another questions, yeah, the point that you mentioned that working on a process to facilitate the design of approaches which not let only AI to do for society good, but also like AI as a collaborator. As a collaborator with the human society to jointly come up with human ideations to solve the solution. I think that might be a more sustainable and meaningful solution for addressing the human problems. So if you're utilizing only AI to address the problem, I think that, yeah, from human psychological perspective point of view, that might not be more sustainable if while comparing the solution which comes from the human with some support from machines agency. I mean, that might be more meaningful work. Okay, Professor Mai, thank you very much for your wonderful speech and talk, and once again giving us your time to join as a keynote speaker. And we would like to have more opportunity to have you here in Japan and another conferences. Yeah, thank you so much.
Well, thank you so much for inviting me. And I appreciate your closing remarks, because I think many people are worried about what happens to humans if AI gets too smart. And I think if we change our focus, that it's about humans, AI helping humans be smarter, then, as you say, it's a more sustainable solution. And it's about leveraging AI for us and not to build AI to compete with us, but to make us better. And I think that's a very important message here.
Yeah. That's very important. Like as a collaborator, how to make systems to work as a collaborator, not to act or represent human agency, because that might be biases and insight might not be accepted as informed policy making. So if we involve human in this circle or loop, and the human will be as a key representative or agents to in this circle, then there might be more valuable on insight, like as a social elements, because we are humans, so we more rely on human creativities rather than a machine creativity. But if there is as a support from AI or machine to make that creativity more, how to say, accurate or concise or valuable, or like support that process, that makes sense. And that's really, I think, next generation focus on AI machine environment. Like, for example, next generation social network not only remain social network, of course, that might be a machine social network. Yeah, something like that. Thank you so much, Professor. And I will ask Professor Ito to conclude this keynote if he has any.
Oh, okay. Thank you very much. So I think time is come. So thank you very much.
Well, thank you.
Thank you.
Okay. Bye-bye.
Bye-bye.